Hello guys, welcome to today's tutorial. In this tutorial, I'll be presenting the solution of this GCE problem that came in 2021 under probability, both from paper 1 and paper 3. Now, from paper 1, we have that if the probability of A intersection B complement is 3 on 20 and the probability of A intersection B is 1 on 4, then what is the probability of A? Solution. To solve this problem, I am going to first of all express A intersection B in terms of A and A intersection B using the Venn diagram representation of those two sets. So if I draw a small Venn diagram like this containing the two events A and B, I will now shade the region that represents this event. That region is this one. This is the region that represents A intersection B complement. Now, how do I express A intersection B complement in terms of A and A intersection B? To do so, I'll simply read. Looking at the shaded portion, you see that this shaded portion is just part of A, excluding this intersection. So I can write A intersection B as A minus A intersection B. So A intersection B complement is actually A minus A intersection B, which, taking the probability of both sides, gives us the probability of A intersection B complement as the probability of A minus the probability of A intersection B. Now, the question gave us the probability of A intersection B complement, gave us the probability of A intersection B, and then asked us to find the probability of A. To do so, we simply make the probability of A the subject. That is, taking this one to the other side, we have the probability of A as the probability of A intersection B complement plus the probability of A intersection B. Now substituting their values, this one was given as 3 on 20 plus this one was given as 1 on 4. Simplifying, the LCM here is 20. 20 goes here 1, we are left with 3, plus 20 goes here 5 times 1 gives us 5. Simplifying further gives us 8 on 20. And scaling down this fraction gives us 4 is a common factor, so 8 divided by 4 is 2, and 20 divided by 4 is 5. So the probability of A is 2 on 5, meaning that from the question, C is the correct answer. C is the correct answer. Now, the second part, paper 3. Paper 3 has two parts, Roman 1 and Roman 2. Roman 1 says A and B are two events such that the probability of A is half, the probability of B complement is 5 on 6, and the probability of A union B is 5 on 12. Find A, the probability of A intersection B, and B, the probability of A given B complement. To solve this problem, we are going to apply the addition law of probability, which states that the probability of A union B is actually the probability of A plus the probability of B minus the probability of their intersection. So, since the question wants us to find the probability of the intersection, we simply make it the subject. That is, the probability of A intersection B becomes, we take it across and this one this way. So it becomes A plus the probability of B minus probability of A union B. Now the question gave us the probability of A, which we can substitute, and the probability of A union B, which we can also substitute. But it did not give us the probability of B. Rather, it gave us the probability of B complement, which means that we have to find the probability of B from the probability of B complement. To do so, we have that the probability of B is normally 1 minus the probability of B complement. So this is going to give us 1 minus 5 on 6, which if we simplify, it gives us 6 minus 5, which is 1 on 6. So the probability of B is 1 on 6. Therefore, we are saying that the probability of A intersection B, we can now substitute, is equals to the probability of A, which is 1 on 2, plus the probability of B, which is 1 on 6, minus the probability of their union, which is 5 on 12. Taking the LCM, which is 12, it goes here 6 times, plus here 2 times, and here 5 times. Simplifying this, we have 6 plus 2 is 8, minus 5, which is 3 on 12. And if we scale down this fraction, if we scale down the fraction, it gives us 1 on 4 as the probability of A intersection B. The second part of the question says a bag contains 3 red balls, 2 white balls, and 1 blue ball. 2 balls are drawn at random from the bag, one after another, without replacement. C. Draw a tree diagram to illustrate all the possible outcomes of the draws. Hence or otherwise, find the probability that D. A blue and a white ball are drawn. A. The second ball drawn is red. So, to draw this is an experiment. Before we draw the probability tree diagram, we need to understand what is going on here. This is an experiment involving 2 trials. The trials are taking balls from a bag that contains 3 red, 2 white, and 1 blue ball. You take out the first, you keep it aside, and then you send it in your hand and take out the second ball. So this our tree diagram is going to contain 2 trials, and each trial is going to have 3 branches for the balls, red balls, white balls, and white ball. So here we go. We have I will let R denote red balls, W to denote white balls, and B to denote blue balls. Now, for the first trial, the sample space is we have 3 red, 2, 2 white, and 1 blue balls. This gives us the number of elements in the sample space as 3 plus 2 is 5, plus 1 is 6. So, our tree diagram now. I have this, I have this, I have this, I have this. So I can put red here, white here, and blue here. This will be red, white, blue. The same here, red, white, blue. And here, red, white, blue. Now, this is our tree diagram, but it's not yet complete since we have not yet represented the probability of each event here. From the first trial, what is the probability of taking out a red? The probability of taking out a red is 3 out of 6, since there are 3 red balls in that bag. And the probability of taking a white is 2 out of 6, and that of taking out the blue is 1 out of 6. Now we are done with the first trial. When we go now to the second trial, on the second trial, we notice that the sample space has reduced. The number of balls in the sample space The number of balls in the sample space has reduced to 5 because a ball was taken out from the first trial and not replaced back. Now, if we consider the first branch of the first trial, which is red, meaning that a red ball was taken out, the sample space now goes down to two red balls, two white balls, and one white ball because a red ball was taken out and not replaced. So what is the probability of taking out another red ball again? This time around it will be 2 out of 5. Then the number of white balls remain 2 out of 5, and that of blue balls is 1 out of 5. If rather it was a white ball that was taken, then the number of white balls has reduced by 1, which means as it was initially 2, it is now 1, and the sample space has gone down by 1, which means from 6 to 5. The number of red balls remain the same, and the number of blue balls also remain the same. But if rather it was a blue ball that was taken out, it means that the number of blue balls, which was initially 1, has gone down to 0 out of 5 because the sample space has gone down by 1. And so the number of red balls remains 3 out of 5, and the number of white balls remains 2 out of 5. So this is our complete probability tree diagram. I'm now going to represent the events beside it. This one, we have the probability, we have red and red. These other branches, red and white. These other ones, red and blue. Then this one, red and white and red. This one, white and white. This one, white and blue. This one, blue and red. This one, blue and white. And then this one, blue and blue. With this, we can now answer the D part of the question, which is we should find the probability. Find the probability that a blue ball and a white ball are drawn. We come back to these events and identify the event that satisfies that condition. That means a blue ball and a white ball. Where is it? This is it here. A blue ball and a white ball. And so the probability will simply be, what was the probability of obtaining a blue? It was 1 on 6 times the probability of obtaining a white, which was 2 on 5. Simplifying this gives us 2 goes here once, 2 goes here 3. So we have 1 out of 15. E says, what is the probability that the second ball drawn is red? Probability that the second ball drawn is red. We still come back to this list of events and identify that event. So here we are going to have this particular event has the second ball as red. So we'll take it. This one does not have the second ball is not red, so we'll not take it. This one, the second ball is blue, we'll not take it. This one, the second ball is red, we'll take it. This one, the second ball is also red. I think that's all. So we have 3 of them. This, and this. So this is actually the probability of red and red, or white and red, or blue and red, which we now add as the probability of red and red plus the probability of white and red plus the probability of blue and red. Now, what was the probability of red and red? We come back here, we have this is red and red, so 3 on 6 times 2 on 5. 3 on 6 times 2 on 5 plus white and red. This is white and red. So white and red, we have 2 on 6 and 3 on 5. 2 on 6 and 3 on 5 plus blue and red. Where is blue? This is blue and this is red. So 1 on 6 and 3 on 5. 1 on 6 times 3 on 5. This is going to, simplifying this will give us, this time this is 6 on 30 plus 6 on 30 plus 3 on 30. The LCM is 30, so we can add the numerator since the denominators are the same. This is going to give us 6 plus 6 is 12 plus this is 15 on 30. If we scale down the fraction, we have 1 on 2 as the probability that the second ball is red, completing the solution of this GCE problem. Thank you for watching.